Hello, my name is Felix Steinhäuser and I'm going to talk about 3D printing of metals. So, to give you an overview, first I'm going to talk about what is 3D printing, then I'm give you a few examples for types of metal printers, then I'm going to talk about sintering versus melting, which occurs in the machine and how it affects 3D printing. Then I'm going to talk about the complete process of 3D printing, and then I'm going to show you some area of applications. To the introduction. 3D printing is a form of additive manufacturing, so you add material instead of subtract like in a milling process. You create a three-dimensional solid object from a digital file like an CAD file. It works like this, that the printer is laying down successive layers of a cross-section of an object and build it this way up. Now I'm going to talk about the types of printers. There are many different types and possibilities of 3D printers, but here are the most common 3D printers of metal. First of all, I'm going to talk about the powder bed fusion. The powder bed fusion uses, like the name says, a powder bed. The material is pulverized and is in the powder delivery system. To start the process, you have different possibilities of heat source. Either you have a laser or an electron source for electrobeams. So this is the first difference in the powder bed fusion. There are three different main parts of powder bed fusion. You can use the electron beam melting, the direct metal laser sintering, or the selective laser melting. Now I'm going to go over the process step by step. First of all, a layer of material is gonna be distributed by the roller over the fabrication powder bed. Then the laser or the electron beam fuses the first layer and forms over the scanner system the first cross-section of the model. After this process, the fabrication piston moves down by the layer thickness and new powder is going to be distributed by the roller. This powder comes from the powder delivery system. And this is the whole process. After the new powder is distributed, the laser melts in combination with the scanner system the new cross-section on it, and you're gonna get layer by layer your product. On the right side, you can see how it works in detail. You have different layers, and the laser comes down and melts or sinters the parts together. To the difference between between melting and sintering, I'm gonna come later. Next, I'm going to talk about the direct energy deposition type of printer. This is a special kind of printer. It already needs a workpiece to work upon. Material is provided by a wire or in powder form and is deposited on the surface over a nozzle. Then heat is added to melt and fuse the workpiece with the powder, and it is used, and the heating source is a laser, an electron beam, or a plasma arc. This is a very similar process to the metal extrusion. The nozzle is mostly on a 4 or 5 axis arm, which can move around the fixed object. This is also one of its applications where you can use it in a hybrid machine from milling and printing, where you first can mill something in your workpiece and then later add new material through the direct energy deposition. But mostly it will just be used to add material to a workpiece, not to build a complete structure on its own. Next, I'm going to tell you something about the binder jetting printer. It's very similar to the powder bed fusion, but for sure has a different technique of keeping the particles and the powder together. First, the leveling roller spreads a new layer of powdered metal. Then an inject nozzle passes over the bed and deposits droplets of a binding agent, like a form of glue, to bond the particles together. When the layer is complete, the build platform moves downwards and it all starts from the beginning again. Here we use a ink agent, which is like a glue, to stick the metal together, but we have to, after it's from the 3D printer, we have to burn it to really fix the powdered metal together. It's kind of like the sintering process. First you build up your model or press it. Here in this case you make 3D printing, and then you have to burn it in an oven that it's getting melted together and keeps its form without breaking apart again. Next, I'm going to talk about the difference between sintering and melting metal. First of all, this difference between sintering and melting mostly affects in 3D printing of metals the powder bed fusion machine. There you have different types of processes where you can, like for example, laser sinter an object or laser melt an object, a 3D model. So, without further ado, melting object is really bringing a metal over its melting temperature, liquefy it, and then let it cool, that it get a solid object again. In sintering, you try to fuse particles with a combination of pressure and heat without melting the material. Now, there's one twist at 3D printing. Even if you use the technique of laser sintering, for example, you probably won't sinter correctly, because all the 3D printing machines need to melt the metal powder a little bit, because they have not the advantage of the pressure they can apply on the material. Also, it is very hard to maintain the low temperature that a sintered metal needs without raising the temperature too high that it melts. So mostly it fuses a little bit together with melting, but it tries to achieve the porosity of a sintered metal. Sintering is also mainly used for metals with a high melting point that is hard to achieve the highest temperature that you can melt them together, and is mostly used to reduce the porosity of an object's surface to enhance properties of metals. This is more like unrelated to the 3D printing, but it's important to know what the sintering process is used for. But the most important thing to get from the sintering versus melting part is that you have to decide which characteristics of the material you want to have melted. Is a more solid and stronger version, but the sintered has different characteristics which maybe are more suitable for your plan. Now I'm going to talk about the process around the printing. In the pre-process, you have many other things to do before you can print. One part of it is like designing a CAD part, computer-aided design part. But here are a few rules to follow. This is very important because you can't design as freely as you think you could do with 3D printing because of the layer-wise construction of the models. But you also have different possibilities than, for example, milling an object. Then you have to pulverize your metal. Mostly you buy it just from the supplier who also designed the machine. Then mostly you can print very fastly. You take the design part, put it in the software that works with your machine, and then this automatically slices it. That means it puts your design part, cuts it up in thin layers, which is later then used for the thin layers built up on the 3D printing machine. Then after the 3D printing of metal, you can do, or you have to do some processes to like finish the surface or like the properties. So you have to make first of all, you have to get rid of all the excessive metal powder that is not fused to your metal part. Then you can have a heat treatment to like release tension in the part or harden it, but this is more like the part is already very hard because it has a rapid cooling in the machine, so you mostly get a harder part than if you would mill it. Then for a surface finish you could electropolish it or do something else, like if it needs for electropolishing, it smoothes the surface, but you also could color it with like anodizing, or also for finishing the surface sandblasting, but sandblasting not just smoothens or roughens the surface, it also helps to remove some of the excess metal powder. So this is are the steps you need to consider around the process. Now to my last part, areas of application. You have many different fields like arts and design, like this guitar, pattern making in automotive engineering, mechanical engineering. Where it's interesting, it's medical engineering or dental technologies, because you can like here customize something for your patient or have enhanced properties for ingrowth in your bones or something. That's why it's in a medical and dental technology very useful and probably has also a big future. The last thing is prototyping is for sure one thing everyone is hyped about, because you can get fast results, can do from simple to very complex parts with less it's easier than to do it with a milling machine, because you just have to insert your 3D part into the program, then on the machine, and it automatically prints it. But if you have to mill it, you have to like write a program on your own. Then you have to also have a machine free which is doing it, and have the different tools, and this is a lot more difficult and more time consuming. Thank you for your listening.